and welcome to Composite Online Academy. In this lesson, we want to look at function or composite mapping, which we have introduced in our last lesson or our previous lesson. We talked about composite mapping as a mapping or a special form of mapping whereby we have three sets: the domain, the codomain, and the codomain produces another set, which is now the final codomain. So the main domain, the images in the main domain, the elements in the main domain will produce images in the codomain, and those images in the codomain will now produce the final images in the second codomain. So the first codomain is an intermediary or middleman set between the three sets. So we have something like this is the main domain, which contains elements. Then the elements in the main domain will produce images in the codomain. Now this codomain will now produce the final images in the second codomain. So let's call this one D, or let's call it D1. Now it will produce images in the codomain, this codomain, which is an intermediary codomain. So let's call it D2, since it will become in another domain that will produce images in the third set, which is now the main codomain. So this is how composite mapping works, or how function maps. Now let's look at problems that involve composite mapping. In composite mapping or function, we can be asked to find function of, when you see something like FOG, it means that we have two sets. This is the first function and this is the second function. So in function, we are always asked to find the function of the first function in respect to the second function. I said that we can use any letter to represent a function. Normally we use F, and sometimes we also use G, and we can also use other alphabets to represent function. So this means that F is a function and G is another function. So FOG means function F of another function G. So function of function. Now, how can we solve questions that involve function of function, or how does the question looks like? Now let's look at this example. If we are given a function like this one, if we are given that we have f of x is equal to x plus 1, and we have another set or another function g of y g plus, we have function f of x is equal to x plus 1, and g of y is equal to y plus 1 raised to power 2. Now, and we are asked to find f of g. If we are asked to find f of g, or let's say we have find g of f and f of g, we can be asked to find f in respect to g or g in respect to f. Now let's solve the first one, g in respect to f, that is g of f. Now g of f is going to be g of f. Now g of f means that we should find the function of f in respect to g. So what is our f? We start with f. What is the f function? That is f of x. F of x is equal to x plus 1. So we now say is equal to f plus 1, x plus 1. So we use this x plus 1 to put in the place of f in this g of f. So we just replace this f by this expression for f of x. So it is now going to be g, putting the expression for f of x, we have x plus 1 g x plus 1. So this is now replacing the f here. Now please note that g of f, g o f is the same thing as g f. So whether they put o or not, it is the same thing. So writing g o f is the same thing as writing g f. So if we are replacing this o f by the expression for function f. Now we know that our g, now remember that we said that f of x is the same thing as y. F of x is the same thing as y. So now that we have this as f of x, it now means that g of, we replace this now becomes y for this equation, and from this our original question we have that g of y is equal to y plus 1 raised to power 2. So it means that y is equal to this. So we now say x plus 1, this is y, then plus 1. Remember that g of y is equal to y plus 1 raised to power 2, and this x plus 1, this first one is representing y, then plus this one that is here. So that is why it is like this. And now we solve this. Solving this, we become the raised to power 2. So we have x, 1 plus 1 is 2, x plus 2 raised to power 2. X plus 2 raised to power 2 is the same thing as, if you solve this, we are going to get x raised to power 2 plus, let's write it out, that is x plus 2 bracket x plus 2. So we have this going to this, and this going to this, then this coming to this, and this coming to this. So we have x raised to power 2 plus 2x plus 2x plus 4, and that now gives us x raised to the power 2 plus 2x plus 2x is equal to 4x plus 4. So this is the final answer. So g of f of function g of function f is equal to x raised to the power 2 plus 4x plus 4. So this is how to solve this question. Now let's look at another example. Assuming we have that f of x is equal to 2x raised to the power 2 minus 3, and we have that g of x is equal to x plus 1. Now let's find g f, that is g of f, and let's find f g. Solution g f, we start with f. The expression for f, we use it to replace the function f here. Then the expression for f is equal to, it becomes g of, expression of f is 2x raised to the power 2 minus 3. 2x raised to the power 2 minus 3. Now, gx now is now equal to gf is now equal to 2x raised to the power 2 minus 3 plus 1 plus 1. Why? This is because in the equation given to us, g of x is equal to x plus 1, and from here x is this, so we use this to put in place of x, and then we add the 1 that is here. So that is why it is this. So it becomes this. Now we can simplify this to get our final answer, and it becomes 2x raised to the power 2 minus 3 plus 1 is equal to minus 2. So this is the answer. Then let's look at f of g. F of g, we start with g. G is equal to x plus 1. G is equal to x plus 1, so we go there. We have f brackets x plus 1. Now we find the function of x plus 1. We know that from f, we use this value to put in place of the value of x in f. So we are going to have 2 brackets we already have that x is equal to x plus 1. So it becomes, remember that our f is equal to 2x raised to power 3 minus 3. 2x raised to power 2 minus 3. So the g which we now have as our x, we use it to replace x here and raise it to power 2 and then minus x. So we now have 2 brackets, this is our g, x plus 1 raised to power 2, then minus 3, as we have in f. So solving this, we are going to get 2 brackets x raised to power 2 plus 2x plus 1 minus 3. Why this? It is because x plus 1 raised to power 2 is equal to so we use this and times this and use it and times this and use this and times this and use it and times this. So it's going to give us x raised to power 2 if we use this and times this, then plus we use it and times 1 plus x, then we use this one and times this, then plus x, we use 1 and times 1 plus 1, so it becomes x raised to power 2 plus x is 2x plus 1. So that is why it is here, it is this. Now we simplify this to get our final answer. So our final answer is going to be, x raised to power 2 plus x raised to power 2 plus 4x, that is 2x raised to power 2. Use these 2 times this, use it and times this and use it and times this, plus 4x plus 2, then minus 3. So it is going to be 2x raised to power 2 plus 4x plus 2 minus 3 is equal to minus 1, then minus 1. So this is the final answer. So this is the f of g. F of g is equal to 2x raised to power 2 plus 4x minus 1. So this is basically how we solve function of function or composite functions or composite mappings.